In this video, we will consider an application of a normal distribution problem. So let's say that x is the number of miles that the new tire will last. And from testing, we find that the mu or the mean is 36,500. So on an average, that's how many miles the tire will last. And we found the standard deviation to be equal to 5,000 miles. So that's what the data is telling us. And we are interested to find out two scenarios. The first scenario is what percentage of tires will last for more than 40,000 miles. Here's 36,500 miles, uh, and 40,000 will be somewhere here. And we are interested to find more than questions. We want to take extra care in reading the exact word. So more than would mean that we are interested to find out this area to the right of 40,000, right? So that's what our question mark is. How much is that area? To do so, the first step is to see or figure out that when x is 40,000, how much is z equal to? So you standardize this. So basically you're saying that instead of thinking of just instead of thinking of x, let's standardize the value of x's and center at 0 and have sigma equal to 1. So you convert this x into the standard normal, and then since standard normal table you can use to figure out the probability. So here you are saying that we are interested to find out the area to the right of 40,000 is same thing as saying how much is the area to the right of this particular point on the z scale. So whatever is 40,000 on an x scale, how much is it on a z scale? So you convert for x, when x is 40,000, z is equal to uh, x minus mu over sigma, and that is equal to 40,000 minus mu 36,500. So now we are centering it, and then divide by sigma so that you get standard normal. So that turns out to be 0.70. So whatever is 40,000 on x scale is 0.7 on the z scale in the standardized scale. And then in the second step, the probability that x is greater than or equal to 40,000, that is what we are interested to find out, will be equal to the probability that z is greater than or equal to 0.7, right? And as you would recollect or know from the other video that I have on reading this table, is the standard normal distribution table always gives the area to the left of some point, and so we are interested to find out the area to the right of 0.7, and which will be nothing but 1 minus probability that z takes value less than or equal to 0.7, right? So this area is this whole is 1, the entire probability space is 1, and then you exclude this area to the left, you'll get the area to the right, and that is nothing but the area to the right of 40,000, right? So area to the left of 0.7 is 0.7580, and that gives you 0.2420. So this area is 0.2420. The second kind of question that one might be interested would be to say in the tire example, is that the company wants to offer a replacement guarantee to all the customers, but at the same time the company does not want more than 10% of the customer to benefit from this guarantee. Of course, the company will offer to all the customers, but company wants to code the guaranteed miles in such a way that they want the 10% of the customers to use this guarantee program, basically meaning that you are interested to find out, unlike in the previous case where we are interested to find out the area to the right of 40,000. Here we are interested to figure out some x. Remember, x is the number of miles, and we want to figure out x, right? And so we are interested to find out one x, some particular x, the guaranteed x, in such a way that 10% of the customers will use this replacement, or 10% of the tires will last for that many miles, the guaranteed miles, only 10% and not more. And so 10, of course, percent is a number less than half, 0.5 or 50%. And so we are looking at this 10% and we want some x. So let's say x1. We want to figure out x1. We want to figure out x1 such that this area to the left of x is 10%, right? So for that, now notice, now we are given the area, we would like to figure out the x. Steps remains the same, right? Now we are not going to get x, but we are not going to get z, but we are still going to use the same idea of getting z for some x1, um, for which we'll get some z1, and divided by standard deviation. We know that x1 we don't know, that's what we want to figure it out. Mu is 36,500, sigma is 5,000, it's given to us. And what is this number, right? So again, I will take the same example of using this z standard normal, and then mu is equals to 0. We want some z1 such that this area is 10%. How does one get it? Well, you do the same idea. You go to the table, the standard normal table, and look at an entry which is as close as possible to 10% or 0.100, and you will notice the entry which is close to 0.100 is row called -1.2 and the column which is labeled 0.08. So the z value is -0.28, right? So this is -1.28. Now you just solve for x1 then. Once you do this, you can then -1.28 times 5,000 plus 36,500 will give you your x1. So your x1 turns out to be 30,100. So if the company offers guaranteed miles of 30,100, the company knows that more 90% of the tires will last for more than 30,100, and hence 90% of the customers will not be coming to asking for replacement, and there are only 10% of the tires which last less than 30,100, and hence these customers will ask for replacement of the tires.